Let's look at fractions and compare them. Remember, while I was talking of division, I had said that many times when we are dividing, we may be left with a remainder. Let's say we are dividing 3 by 2. So 2 ones 2, a remainder is 1, 1 is left. So the way to write this, the result of this division, that is 3 by 2 is equal to 1, which is the quotient, and then a remainder divided by the divisor. Now this is a short way of writing 1 plus half. Here this is the whole number, and this is a fraction. So whole number, fraction. Now fraction can be of two types. One is proper fraction and the other is improper fraction. Okay, what's a proper fraction? A proper fraction is something which is without whole number. And an improper fraction is one which has a whole number as part of it. Just in the previous example, when we divided 3 by 2, we got 1 and a half. So this has a 1 and a half. So this is a improper fraction. Okay, what about a proper fraction? Proper fraction will be without a whole number. So let's look at 3 by 5, right? This is not containing any, this doesn't have any whole number. So this is a proper fraction. Another way to identify whether a fraction is proper or improper is look at the top number and the bottom number. Now there is a specific name given to this top number and bottom number. Top numbers 2 by 3, this is called the numerator and this is called the denominator. If the numerator is greater than denominator and is not a multiple of denominator, then it is a improper fraction. Okay, let's understand this. Numerator is greater than denominator. So top one has to be greater. So greater means, let's say 6. So which means denominator must be smaller than 6 and is not a multiple of denominator. Imagine this, if this is 2, 6 is a multiple of 2. So they two will get cut off and you will end up with a whole number only. Right? Similarly, if it is 3, then again you will end up with a whole number. So what we want is a number which is not a multiple. So we need a numerator which is not a multiple of denominator, or a denominator which is not a factor of numerator. if we are saying 6, you can't have 2, you can't have 3, you can have 4, but then it is not, it can be simplified further. I'll come to that. 5, right? So 6 is, the numerator is bigger than the denominator, but at the same time 6 is not a multiple of 5. This is a improper fraction. Okay, now if numerator is smaller than denominator, then it is a proper fraction. Let's look at 2, and below you can have anything greater than 2, right? So if we have 3, we can have 3, we can have 4, we can have 5, anything. Then it is a proper fraction. That is one thing. If they are equal, if the numerator is equal to denominator, in that case the number is always 1, right? How? I'll tell you. Okay, now imagine or think of a number something like 3 by 6, right? 3 by 6. So how can we imagine this, right? 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 4, 5, 6. Out of that 3 out of 6. So shade 3 of them. So this is 3 by 6. Now suppose something similar I do, but this time I divide it into half. So this is 1, this is 2, and I shade 1 of the 2. So this is 1 by 2, right? So which means what? They both look same, isn't it? We can arrive at 1 by 2 from 3 by 6 by simplifying it. Now simplifying it means what? Dividing both numerator and denominator by the same number. 3 1s 3, 3 2 6. So we end up with half. We can do this further. Let's say 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. So 4 out of 8. Again look similar. So 4 1s, 4 2s. So here in all the 3 cases 1 by 2 is in the simplest form. So whenever we are doing anything with fractions, if it is there in the simplest form, it makes our life easier. The calculations become simpler. Okay, now let's do the comparisons. Which one is greater? Which one is smaller? So 5 by 6, 1 by 9. Now whenever you are doing comparisons, if the denominator are same, for these two fractions, if the denominator is same, then it becomes simpler. So how do we make the denominator similar? Find the LCM of 6 and 9. So remember, in the last session we saw how to do that. 6 and 9, 3. So 3 3s are 9, 2s are 18. So 18 is the, so 18. 18 is the denominator now. But to get 18, what do we have to do? We have to multiply by 3 here. So which means if we do that, the fraction changes. So to make sure that the fraction doesn't change, we multiply the numerator also with 3. So here we have to multiply it by 2 to get 18. So now the numerators, when we multiply 15 by 18 and 2 by 18, we can do the comparison. For example, look at here. Which one is 15 out of 18 is bigger, or 2 out of 18 is bigger? So naturally 15 out of 18 is bigger, so it is greater. This LCM makes all these comparisons very, very easy. So again, so what do we do? 3 and 8. What is the LCM? 24. So 24, 24. So to get 24, we have to multiply this by 3 and this by 8. So which means into 8 and into 3. So 15 by 24 and 8 by 24. So which is greater? 15. 1 by 2 and 1 by 8. Now here what's the LCM? Remember, if one of the two numbers for which you are trying to find the LCM is a multiple of the other, then that is the LCM. So here 8 is the LCM because 8 is a multiple of 2. Multiply 4, so we get 8. So this becomes 4 by 8, 1 by 8. So this is greater. Okay, what about something like this? 1 by 3 and 1. Now, a proper fraction is always less than 1 by definition. So 1 by 3 is less than 1. 1 by 2 and 2 by 3. 1 by 2 and 2 by 3. So again, multiple, common multiple LCM is 6. So 6 into 3 into 3 into 2 into 2. So 3 and 4. So 3 by 6 is less than 4 by 6. So which means 1 by 2 is less than 2 by 3. 4 by 5 and 2 by 3. So again 15 is the LCM. So into 3 by 3 into 5 by 5. So 12 and 10. So greater. Same thing we can do with 2-digit numbers also. Okay, now what about negative numbers? Negative numbers. So let's change the range from -9 to 9. Just remember, if one of them is a negative number, then the other is a higher number. So positive number is always greater than negative number. So 5 by 7 is greater than -3 by 4. If both of them are negative, -7 by 8 and -1 by 2, you have to find the LCM. So here LCM is 8. Okay. So -14 and -8. So here which is 14 by -14 by 8, -14 is smaller or -8 is smaller? minus 14 is smaller. So minus 14 by 8 is smaller than minus 8 by 8. Okay, now what about a comparison like this? Minus 5 by 7 and minus 1 by 1.5. Now the moment you have a whole number, that is a complete number, and the other doesn't have a complete number, you can, by just looking at it, know which is bigger. So here minus 1 is bigger, or remember this can be written as what? Minus 0 plus 5 by 7. This can be written as minus 1 plus half. So which is bigger? Minus 1 or 0? 0 is greater than minus 1. So 5 by 7 is greater than minus half. Minus 5 by 7 is greater than minus 1.5. Or what you can do is convert this mixed fraction into so that it is shown as a fraction without whole number. Now 1.5 can be written as, here you multiply this and add this. So 2 ones 2 plus 1 3, 3 by 2. So the comparison becomes minus 5 by 7 and minus 3 by 2. Again LCM. So 14 minus 10 and minus 21. Okay. So minus 10 is greater than minus 21. Yes. You can choose whichever method you want. Remember, you cannot do division by 0. If somebody says what is 5 by 0, you just say undefined. If it is asked 4 by 0 and 3 by 0, which is greater? Don't look at 4 and 3 at all. The moment you see 0, you say undefined. Okay, so that is as far as comparing fractions is concerned. Now practice again. If you want this Excel worksheet workbook, just drop me a mail and I'll send it across. Okay, while going through this, I realized that I made a mistake. If you remember, we were comparing 7 by 8, minus 7 by 8 and minus 1 by 2. LCM is 8. So actually this would not be minus 14. This would remain minus 7 and this would be, remember, this into 4 into 4. This will be into 1 into 1. Okay, so that is how the denominators will become 8. So minus 7 by 8 and minus 4 by 8. In which case, which is smaller? When it comes to negative numbers, the farther away from the 0 is, the lower it is. Or in other words, minus 7 is to the left of minus 4. So it is less. So that was a correction. Bye for now.